So as I mentioned, I'm pulling my notes from my statistics class on statistics in section 4.1, but of course we are talking about 8.1 and 8.3, looking at scatter diagrams and correlation. And then we also have one other section that I want to pull from. All right. So a scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point, and those points are created by your explanatory variable and your response variable. If I scroll up too fast, let me know. Of course, I can't see anybody to know who's writing or not. So,
Okay.
Just slow your roll right there now.
all I do is move up right to the left.
That's what I said right there, though.
So, Ms. Gallup, you want to be our gauge and you let me know when you finish, and then I'll scroll. Yeah. Maybe that'll help us. It's kind of hard when I've already written notes, so it's like nobody's waiting on me to finish. You know what I mean? So.
Right. I'm doing the best I can over here.
You're fine. You're fine.
And when we have our exam, it'll be kind of like, we'll have a couple of questions like this, and it'll be like blanks, kind of how it was before with the definition version, right?
Yeah. Well, it's going to be just like we did the last one, where basically I pulled problems from each one of the previous sections and everything, and then put it all together into one test, and you'll have a review.
Yeah.
Set up like that, and it'll let you know what's going to be on it.
You know what I mean, Mr. Tucker? I'm just trying to get ready.
You're fine.
Like last, what is it, like 3 weeks? Or no, not 3 weeks. I'm sorry, like 4 weeks, something like that.
We talking class? How much class time's left?
Yeah, like everything, period. You know what I mean?
Uh-huh.
Yeah.
Yep, about 4 weeks.
Ready for that break, but honestly, I feel like it's gonna go by so fast.
Hey, don't Thanksgiving break.
Well, that, and then like we finish, like school. You have the winter break kind of thing,
Mm-hmm.
Yeah, I don't think that'll be long enough. I feel like, shoot, it's already 2021.
Yeah, Nova State is not going back until January 27th.
Wait, what?
Yeah, I was surprised. Yep.
Really?
Uh-huh. I don't know if TCC is going to follow, but
Yeah. Well, I hope to God, because I really miss and I really wish we could sit in class right now and copy these notes.
right. Well, they're not going back to class. They're just not starting. Well, let me say this back. They're not starting the spring semester until January 27th.
Okay.
Yeah. No, they're still not going back because it's still,
Right.
stuff is still out there.
I'm good, Mr. Tucker.
Okay.
Okay.
All right. Difference between your explanatory variable and your response variable. Explanatory explains the value of the response variable, and the response variable is explained by the explanatory. And I'll show you an example in a second what we mean by explain versus not being explained. Also, your explanatory variable is your X, response is your Y, so that should be more familiar to you. So that means is your domain, your input, and your independent variable, horizontal axis, and then the other one, your response is your Y range, output, dependent, and your vertical axis. Hold on 1 second. Okay. No. All right, scrolling up. Thank you. Okay, and then here, where's my pen? Here's just a general. I just put some points in, just general idea of what a scatter plot look like. It's just going to be using your first quadrant. Your explanatory variable will be down here, and your response variable will be here, your vertical axis. And you'll plot points just like you would on an XY chart. So if you ever thought about what is an application, why would I use, graphing? This would be one of them. You'd be able to compare data sets and all the good stuff like that, compare information. All right, hold on once. Let me look at something I'm looking for. Where is, okay. All right, that's way down there. All right, so go back up here. That's where we are. Let me know when you're ready. You guys are ready to go down.
Thumbs up for me.
All right.
I'm good.
Yes.
Sounds good.
Would we like in real life, like unless you're like an engineer or something, when would we use like graphing? You know what I mean?
You said when?
Yeah, like what? I don't know. Like, yeah, I get it.
Oh, well, I'm going to give you an application or just a simple example. But
Right.
basically, when you're doing it in statistics, you're doing it to either compare data or to show people a trend
Okay.
or a pattern, which is what we're about to look at now, your linear relations or your linear relationships.
Okay.
When a line best sums up the shape of the scatter plot. And so if you remember, I believe it was last class when we were drawing a line through our points
Yes.
and seeing what best sums up that relationship.
Yeah.
This is what we're leaning on, a linear relationship. Because having a linear relationship is a better way to explain a pattern than something that's chaotic. There's no real proof that there is a relationship there. So if you can find a linear one, then that'll be good. So like in this first one, see most of your points are going up and a line is what best describes what's going on. And the second one as well. So now in the third and fourth one, here and here, it's not saying that we don't have a relationship. It's just not linear. Linear is line. So here we have an arc, but there definitely is a pattern or relationship there. It's just not linear. And then same thing here was like a wave,
Yeah.
but it's not. There's a relationship there. It's just not linear. And then in that last one, there's no relationship at all.
Okay, so it's just an easier way to like get your point across without having to write everything out, I guess.
Yeah, exactly.
Okay. Cool. How's everybody doing? Y'all with me? Shoot. I'm good.
Yeah. Let's see a little more of the nonlinear. Okay.
So that purple says nonlinear does not mean no relation, just means no linear relation. All right. So positive associations or positively associated. When one value increases, the other one increases. So in other words, when you look at your points and it's going up, when you go from left to right, when you're following your pattern, you're going from left to right. If it's going up, that's considered a positive association. And then if you're looking at your points going from left to right, if they go down, that's considered negatively associated.
I'm good.
All right. Let me know if I'll go up too far. All right. So your linear correlation coefficient is a measure of strength and direction of the linear relation between two quantitative variables. I didn't see where you guys needed the what is it called? The symbols for the correlation coefficient. But Greek letter rho is the population correlation coefficient, and R is the sample correlation coefficient. But never know.
Can it always be something else, or is it just going to normally be P and R for those?
Well, first of all, that is not P, that is rho.
Oh,
Okay, that is Greek letter rho.
okay.
I'll just mess. But yeah.
I don't have my glasses on.
Oh, yeah, that's Greek letter rho. So only reason, and I'll just mess with you about that.
I know.
Those are the only two letters that you will use. And I believe we talked about in this class how your population will have
Mhm.
certain symbolism, and your sample will have another set of symbolism. So rho would fall in with the population symbols, and
Okay.
then R would fall in with your sample symbols. And but yeah, those are the only two letters that you could use to represent the correlation coefficient. All right. So we good. Don't worry about the blue. You don't need that blue.
Okay.
So can I go? Anybody need it?
Well, you're recording it too, right?
Yes. Mhm. Do I need it? Okay, good. All right, so now we're looking at the properties of the correlation coefficient. As far as the stuff that you guys have, some of you need, some of you may not, but you'll be all right.
Mhm.
I haven't made y'all copy some real notes the whole semester.
Kind of excited, to be honest. Well, it's so crazy because before I was like, God, I hate driving to school, but now it's like I actually want to be there. It's all good. Staying at home's the worst.
Yeah, yeah.
It
The
really
the value of leaving the house.
yeah. Is.
So,
Enjoying getting stopped behind a school bus.
yeah.
Oh, I miss the school zone. My God, I used to hate it.
Right, right.
Yo, hurry up! And now I'm like, I would just bask in it. I would just your time. Like, oh,
So the correlation coefficient is going to be in between -1 and +1, inclusive. So I mean, you can use it as -1, or it can be -1, it can be +1. If it is +1, then a perfect positive linear relationship exists, or relation exists. If it is -1, then a perfect negative linear relation exists. So the closer R is to +1, the stronger the evidence of a positive association. Closer R is to -1, the stronger the evidence of a negative association. Oh, somebody come in. All right, so going on to number 6. If R is close to 0, then little or no evidence exists of a linear relation. And then it goes back to what I said earlier. R being close to 0 does not imply no relation, just no linear relation. And so like I mentioned before, as far as you guys and your assignment, I don't think you have to find the correlation coefficient, but you have to apply the thought process behind what a correlation coefficient means. So you may not have to worry about R being close to 0, but you know that the linear relationship part, I still saw things that asked you about that. So,
right.
yep, yep. So the workings behind it still valid for you guys. So it is a unitless measure of association. And that last one is not resistant. That means it's affected by outliers. And outliers are extreme values. Once again, that's something that you guys are not going to have to worry about, but it was just one of the characteristics or properties of a correlation coefficient. All right.
Whoa. Wait a minute.
Say go. No, I think
Come
you said go. No,
No.
just
No, see, 7 is good for me. I don't know about anybody else. Okay, yeah, that's good.
So as we get down there, just this generic representation of what it means for R to be one and then to go away from one. You know, positive, that perfect positive linear association is the first one. Then as you start to spread, it starts to get further and further away from one, going to 0.9 and to 0.4. And you'll see the next few.
And number 8,
Mm-hmm,
it is not resistant, and then it is affected by what?
Outliers.
Outliners.
Outliers.
Liars. Oh, okay.
Outliers, yeah. Extreme values.
Okay.
I'm okay, y'all.
All right, I think we can go up there. We're done with 8.
Oh.
It is not cute.
I know. I'm in the top
Downstairs.
because I'm like, oh. I get it. I know. You're like,
It's cute to everyone except the one that's happening to, right?
I know you're like, oh, like, dark. Oh, I just throw this table up. Like, oh, man. Now it makes me think, how do people actually, like, before all this happened, like, people that worked from home, like, like that's hard. It's hard. I don't know.
Yeah,
Like,
it is. But I've heard, you got to do the call centers because there were call centers that were doing this stuff from home even
right.
before the pandemic. You would hear people, kids in the background. It's like,
Mm-hmm.
Okay.
yeah, you just had to catch the right one. That's all.
Yeah.
My mom used to telework before the whole entire pandemic started, and our 2 dogs bark at anything they see move around in the cul-de-sac. And so we would physically have to shove them in their cages for half the day in order for them to just like get their work done.
Wow.
Wait, you put a child in a cage?
What?
Dog.
Dog.
I had the coffee. I'm sorry. I'm sorry.
Oh, man.
Okay, I feel that. I get it. Yeah.
That is too funny.
Jesus.
right, can we scroll? We good?
Yes. Yes.
Okay, cool. I didn't see where y'all need this. Okay, here. Determine whether a linear relation exists between the club head speed and distance. So we have a golfer here. And the reason why I wanted to go through this is that just to give you an example of a explanatory variable versus a response variable. So here we have a golfer here swinging his club, and the club head speed is how fast, he's swinging the club, and then the distance that the ball travels. So the explanatory variable is the club head speed. The distance the ball travels is a response variable. So in other words, how hard he swings the club or how fast he swings the clubs will explain how far the ball travels or dictate how far the ball travels. All right. So that's the difference between your explanatory variable and your response variable. Your explanatory variable will be the one that actually dictates or explains why the response variable is occurring. So that's all there is to that. And so what I told that class, you guys didn't have to find this correlation coefficient anyway, so you don't have to worry about that. But I just went here just to show you the difference between your explanatory variable and your response variable.
So we don't have to take down all like the explanatory and the response.
No, not really. We already really know. I just want to make sure you saw an example of what was the difference between the two. Because remember, I was talking about them, but I never really gave you an example of what was the difference between the two. All right. So is everybody done with this?
Yes.
All right. I think that's it down here. Yeah. All right. Let's go to 4.2. And I did see that they mentioned the coefficient of determination. I think that was an 8.3. So the coefficient of determination, it measures the proportion of total variation in the response variable that is explained by the regression line. That almost looked like an S, but that is an I. Oh, yep, not a problem. So it basically tells us how reliable our regression line is. And it is the correlation coefficient squared. And I believe we had a previous section that talked about a regression line. Yeah. Matter of fact, while y'all copying this, I want to see something. 8.3 go. There we go. Correlation coefficient of determination.
You better answer that, baby.
Ow. You better answer that, baby.
All right, sorry for the interruption. All right, so graphing. Hold on, let me look at this example, see if they actually ask you guys to calculate. So maximum, minimum, per capita. Okay, yep. So you will have to make sure you pick the right graph, but you guys are supposed to know how to graph, so you should be good. Use measurement, linear correlation. Yeah. So yeah, if you lean on these notes, you should be fine. But if you see something that you don't understand, make sure you ask me. So let me go back to the notes. Trying to see if you guys need any more of what I just showed you. Between 0 and 1. No explanatory variable value. Vertical line explains 100% of the response. Um, okay. This right here. Where did I stop? I did this.
You stopped at coefficient squared.
Coefficient squared. Okay, so that's enough for what you guys need. And here, I want to make sure we know what it means. So let's look at this example. So determine and interpret the coefficient of determination for the club head speed versus the distance. All right, give you a chance to copy it. So this was taking the data from that first chart, no, that last chart that I was telling you about. And so you were to put that data in the into a calculator or run the formula yourself, you would have got your correlation coefficient to be 0.939. All right. So to find the coefficient, was somebody saying something? Oh. So to find the coefficient of determination, you would square that, and that would be 0.882, which is 88.2%. If you were to convert that to a percentage.
So we can convert these into percentages.
Well, for this one, the coefficient of determination, you can.
Okay.
Yeah, because of what it represents, and that's what I'm about to give you now. I just want to give everybody a chance to write it. All right. All right. I think that okay. So 88.2% of the variation in the distance is explained by the regression line, or basically it's talking about the strength of their relationship. 88.2% of it's 88% reliable or 88% linearly related. And then it said 11.8%, you're subtracting that from 100 would be the other part is explained by other factors. So in other words, in this case, if you're talking about the interpretation of this situation, we're talking about, swinging your golf club. So other things that could explain why the relationship may not hold true is that when you swung your golf club at one point, maybe the wind was blowing, or maybe you didn't hit it, the same way or something. Anything could, outside of the norm. There's 11% chance that one of those other factors may take hold. So they're just saying that 88% of the time, the relationship will hold true. We're still talking about the regression line. So, yeah. All right. Questions on anything I've said or written. May not have any until you actually get into the assignment. But
So this 8.3 is basically just like word problems. It's going to tell us to find like the relation between the two.
let me see. Did I leave it up? No, I took it down. Hold on 1 second. So I'll pull up 8.1 first. Oh, was everybody done sharing before I move off the page? I mean, not sharing, but copying.
Yes.
Everybody good? Okay. So here, 8.1, what is correlation? So, it's the first one. Try not to give you the answer. Say another definition. Determine a statement that makes sense. So based on what we said, determine a statement that makes sense. I found a strong negative correlation. So that, we talked about what that means, of data relating to a percentage of people in various countries who are literate and the percent who are undernourished. Okay. I conclude that an increase in literacy causes a decrease in undernourishment. And so you have to determine whether it makes sense according to what we said. Does it make sense that if you increase in literacy, it causes a decrease in undernourishment? So you have to pay attention to words as well. Here. So once again, and so when you read these things, I'd rather you guys go through it and say, okay, I have a question on this versus me just giving you these answers. You know what I mean? Because they're not calculation based. It's based on your reading. So so I would rather, like I said, you go through it and then ask me, okay, this didn't make sense. What happened? Versus me just giving you the answers, and really there's no other answer but what I gave you.
Right.
So if you look at all of them, they're all word. Here they give you the scatter plot, and then you have to ask, is there a weak negative correlation? That's what we're talking about. So yep. So that is 8.1.
Okay.
And 8.3 is similar as well. I'll bring it back. And so 8.3 is only 10 questions, but you see it's dealing with the same type of field. And so here you will look at graphing, and then the per capita is on bottom. Well, GDP, I should say, is on bottom. That's your explanatory. And capita defense is on the left, the vertical axis. So that would be your response variable.
Okay. So they're wanting to see if you understand the concept, really.
Say that last part again. You broke up.
Sorry. They want to know if you understand the concept of what it is, pretty much.
Yeah. And going back to the scatter plot, that's just graphing, on the XY, just graphing on the XY axis. So. And so, yep.
Okay.
So that's, I already gave you this answer. I think the same one as well. R, the linear correlation coefficient, represents the strongest negative correlation. Is, and of course, I'm not gonna give it to you, but I already gave it to you. You know what I mean? So. So yeah. So. Yeah. So you see, 8.1, 8.3 is just words.
Yeah. Definitely got some work to do. For sure. Whoever saw it, I feel you. I'm right there with you.
So, but the good thing is, I'm not gonna hit you with anything new
I know. I was
going
just
forward.
about to say.
Yeah, that is good.
Yeah.
Mhm.
To kind of just get caught up with everything,
Yep.
prepare for the test, really, honestly.
Mhm. So just to reiterate, moving forward, I will, I won't really record anything unless somebody say, could you record this? So if you don't get any more videos moving forward, it's because, we didn't, because people just asking random questions or there may be dead space, you know what I'm saying? Just, when you open up the floor for questions, I don't always get immediate information. So it just be like, I might be waiting for somebody to say something. So I just don't want to record just
Right.
air. So if somebody say, can you record this, then I'll record it and then I'll shoot out to everybody. But I'm just saying that, if you were to miss a class and you don't see any recordings, it's because, nothing was said that was, needed to be recorded.
Right.
So, yep, it'll just be on you guys to come to class. If, I'll give you guys 15 minutes, don't nobody show up, and I assume everybody's good for that day.
Yeah.
And then I'll roll on to the next day, but I will show up every class period to see if anybody has questions. And if you're not coming to class, then make sure you're paying attention to your emails.
Right.
Because if I make a class announcement or make an announcement to the class, I will shoot it in the email as well. So just like final exam day, once I establish that, then that will be shot out in the email. And yeah.
Well, I'll definitely be showing up at least for the first 30 minutes. Because I'm tripping. We're almost done. I'm not about to not do it.
Right. So, questions or concerns before we close out today?
Other than I got some work to do.
Yeah.
When is the final?
That I haven't looked at yet. It's just that I know it's going to be before that last day in December. I haven't looked at what exact day we're going to do it. Yeah, but I'll most definitely look at it and put that out there. You most definitely will know, well ahead of time, because our class doesn't end until December 18th.
Something like that, yeah.
SIS says
I think
December.
it's 16th. I think it's the 16th.
And teachers have time to put grades in or whatever they got.
Well, yeah, 16th is that Wednesday. Yeah, so SIS says 18th for all the classes, which is Friday, but we don't go to Friday. We go to Wednesday.
Right.
So December 16th is the last day I possibly could do it. But we may look at doing it that week before.
Yeah.
And then give you till the 16th to do, turn in last minute, my math lab stuff.
That's what I'm talking about, yo. Mr. Tucker, look at this. Come on. Woo, y'all, we have more than enough time. Like, let's.
Yeah. So maybe we'll do it like that week before, do the final test. Yeah. And remember, that's going to be on chapter 4 to chapter 8. We talked about how the midterm was from 1 to 3.
Right.
And then the final test will be from 4 to 8.
Oh, that's cool.
And yep, so we'll probably do that either the 7th or the 9th, and then from there give you till the 16th. Or I might give you to the 18th. Yeah, well, let me see when I have to have these grades in. Okay. Either 16th or 18th to turn in all your assignments.
Yeah, that's way more than enough. Okay, that takes off a little bit of pressure or something. You know what I mean? If anyone else like that, but that's what I'm talking about.
Glad I could help.
Yeah, man. That review about to be nice. I'm telling you. I'm prepared for that.
So, anything else before we close? I'm sure we're good.
Oh, I think we're good.
All right. So I will see you guys on next class. Have a good one.
You too.
Everybody have a good weekend. See y'all next week.
You guys too. Bye, guys.
Good luck.